Good everyone, my name is Graphics. In this video, we want to analyze the circuit that is displayed on the screen using nodal analysis, or you call it the node voltage method. If you look at this circuit closely, you discover that it has three mesh, right? And it has 5 passive elements and 4 active elements. The 5 passive elements are the resistors, which have resistances of 5 ohms, 3 ohms, 4 ohms, 2 ohms, and 8 ohms. While the active elements are the sources, which is the 20 volts, the 5 volts, the 5 volts, 5 volts, and 30 volts. Now, if we are told to use nodal analysis in analyzing the circuit, the first thing you have to do is to detect the reference node. The reference node here is always 0. I'll place it at the base here, right? This is what we have here. We'll call it the earth. Now, we'll identify the node where 3 or more currents meet, right? And this is the node here. Let's say here is A and here is what is B, right? So we have node. And what is the node? The node is the point where 2 or more currents meet. Now if you look at node A, we have more than 2 currents there. If you look at node B, we have more than 2 currents meeting there, right? Now this is what we have here now. Now it now depends on you. You can decide to take any direction of the current. Nothing changes, right? So for the benefit of this video, I will say the current coming from the 20 volts source, right? We'll call it I1. Then put my arrow there. And I'll say the current coming from the 5 volt source this way. I'll call it I4, right? And I'll say the current coming from the 5 volt source here again, I'll call it what? I2. The one coming down here, I'll say it should be I5. And the one coming from the 30 volt source, I'll call it to be I3. Is that okay now? Now it depends, whatever you like you do. One thing you need to take note is that the longer terminal is positive and the shorter terminal is negative. We know current moves from a lower potential to a higher potential. We're taking the shorter terminal here, or would I say the negative terminal to be my lower potential, and the positive terminal here to be my higher potential, right? So whenever I see the short one is negative, so I'll just put that for the benefit of this video, so we'll not make mistakes. Is that okay now? Now after we've done that, then what we're going to do here? We're now going to, one benefit of the node voltage method or the node analysis is to minimize the amount of equation we have, right? So if a normal way the equation ought to be 3 equation, when you use nodal analysis, it will become 2 equation, right? So it makes things more easier for us. So let's start. Now, if you look at the node voltage, is identified as, at this point here, call it VA, and at this point here, we'll call it what? VB. That is the node voltage. Is that taken? So point A, the node voltage there will be VA at the voltage at A, and point B, the node voltage will be what? VB, voltage at what? At B. Is that taken? While our reference voltage here, V, will be what? 0. So we'll start considering each of these nodes one after the other. So if I consider at node A, right? When you consider node A, you remember applying the KCL rule at node A. That's what we're going to do now. And what is the KCL here? We call it the Kirchhoff current law. That states that the total current entering the node is equals to the total current leaving the node, or you see the algebraic sum of all current inside into a node is equal to what? 0. Now I'll put my equal sign here. I'll take the left hand side of the equal sign to be the current entering, and I'll take the right hand side to be the current leaving, right? Now, if you look at the left hand side now, let's see at node A, which current is entering? Discover that I1 is the one entering into node A. You can see the direction of the current. I1 is the one entering into what? Into node A. So I'll put it at the left hand side. Now, the right hand side we know is the current leaving. Let's see which one is leaving A. I2 is leaving A, that is moving away from A, and I4 is moving away from A, right? So it will be at the right hand side. So you'll be adding both of them since both of them are leaving the node A. That's okay. I'm going to term that my equation 1, right? Now, since we've done that, we need to know what the value of I1 is, I2 is, and I4 is. Is that okay? So if I look the I1 here, I1 will be equals to the voltage drop across my 5 ohm resistor, right, will be where the current is coming from, which is the 20 volts, minus where the current is going to, which is VA. Are you with me now? The current is coming from 20 volts and is going to what? The node VA. So you subtract both of them. You get the logic now. Where the current is coming from, 20 volts, minus where the current is going to, VA, divided by what? The resistance between them. Is that okay now? So that's what we have there. And we'll go to the next one, I2. We're focusing on I2 now. Look at I2 here. Where I2 is coming from is VA, right? And where I2 is going to is VB. So VA minus VB. Then with we have another voltage source in between them. And look at, it's going towards the positive terminal, right? So the same direction here. So since it's going towards the positive terminal, so it will be plus 5. So I'm going to add plus 5 to it also. Divided by what? The resistance between them, which is what? 4. Is that taken? Now we'll go to I4. Now the next thing is I4 is, let's look for I4. This is I4 we have here. Where I4 is coming from VA, that is from node A, the voltage at node A, and it's going to what? The reference node, which is what? 0. It will be VA minus what? Minus 0. Now what do you notice? We have another voltage source here, which is 5 volts here. You can see that, and it's moving from the higher potential to lower potential. That is moving from positive to negative, so it will be negative. So we're having VA minus 0 minus 5. Is that okay now? Divided by the resistance between them, which is what? Which is 3. This is what we're having here, right? Which will end up giving us VA minus 5 all over 3. Now we've gotten the current here. Now the next thing is for we to substitute this current into equation 1. So if you look at equation 1, we have I1, and that will be 20 minus VA over 5 equals to I2, which will be VA minus VB plus 5 over 4 plus I3, which is VA minus 5 all over what? All over 3. Is that okay now? So what I'm going to do here is I'm going to write it by saying 20 minus V over 5 equals to, I'll now take the LCM of these two here. The LCM of 4 and 3 is 12, right? So we'll say that 4 in 12 is 3. So 3 times everything that is the numerator of 3 here. So 3 times VA will give you 3 VA, minus 3 times VB will give you 3 VB, plus 3 times 5 is what? 15, right? Plus 4 in 12 is 3 in 12 is 4. 4 times VA is 4 VA, minus 4 times 5 is what? Is 20. Is that taken? Now if I write again, I'll be having 20 minus VA all over 5 equals to, I'll collect like terms. 3 VA plus 4 VA will give me 7 VA, minus 3 VB, minus we have 15 minus 20 will give us minus 5 all over what? All over 12. Now I'm going to cross multiply. So cross multiplying, I'll be having this 12 will come to this point. I'll be having 12 into bracket 20 minus VA is equals to 5 into bracket 7VA minus 3VB minus 5, right? So if I expand, 12 times 20 is 240. 12 times VA will give you 12VA equals to 5 times 7VA will give you 35VA minus 5 times 3VB will give you 15VB minus 5 times 5 will give us 25. So if I collect like terms, I'll be having 240. If I take minus, if I should take minus 25 to the left hand side, I'll be having 240 plus 25. The minus will become positive, equals to 35VA plus 12VA minus 15VB, right? And if you look at 240 plus 25 will give us 265 equals to 35VA, right? Plus 12VA will give us 47VA minus what? 15VA. Is that okay now? 15VB. So I'm going to term that my equation 1. Is that okay now? So since we've done that, we'll move to the next node. We'll now see that at node B, right? At node B, what we're going to do, we'll do the same thing. If you check node B now, I'm going to put my equal sign here. In the left hand side will be the current entering, and the right hand side will be the current leaving. So let's see the current entering node B. So at node B, the current entering node B, right, will be I2 is entering node B, and I3 is entering node B. So we'll be having I2 plus I3 at the left hand side. Then I5 is actually leaving node B. You can see the arrow here. So that is why it's equal to what? I5 in the right hand side. Is that okay now? So I'll term that what? My equation what? Equation 3. Now look for the value of I2, I3, and I5. So what is the I2? I2, we've already gotten it before, but I'll just do that again from our previous solution. We know that I2 is equals to VA minus VB plus 5 over 4. How do we get that? I2, where is it coming from? It's coming from VA minus where it is going to, which is what? VB. Then look at we have another source here, another voltage here, which is 5. But 5 is moving from lower potential to higher potential, and that will be what? Positive, right? So we have VA minus VB plus 5 all over the resistance in between them, which is what? 4. Is that taken out? Then I3 now, let's see. I3 is coming from what? It's coming from 30 and it's going to what? VB. Look at it is coming from 30, right? Look at the direction, and it's going towards what? VB. So it will be what? 30 minus VB divided by the resistance between them, which is what? 8. Is that taken? And we'll go to I5. I5 will be equals to, we have VB. Where is I5 coming from? It's coming from VB, and it's going to what? The reference node here, right? So it will be VB minus 0. Then we have a voltage in between them, so it's moving from lower to higher, so it will be plus. So it will be VB plus 5 minus 0 divided by the distance between them, which is what? 2. So we're having VB plus 5 all over 2. Is that taken now? So we will now substitute this value into equation 3. So if wherever I have I2, I will put what? VA minus VB plus 5 over 4, right? Plus I3, what is I3? Which is 30 minus VB all over 8 equals to, what is I5? I5 is what? VB plus 5 all over what? All over 2. Is that okay now? Now look for the LCM here of 4 and 8, and the LCM is 8. So to having 4 and 8 is 2. 2 times VA is 2VA. 2 times VB is 2VB. Plus 2 times 5 is 10, right? Plus, now 8 in 8 is 1. 1 times 30 is 30. And 1 times VB is what? VB. Equals to, we have VB plus what? Plus 5 all over what? Over 2. Is that okay now? So in doing that, we will now collect like terms. We'll cross multiply. So we'll cross multiply now. We'll be having 2 into bracket 2VA minus 3VB plus 40. Is that taking equals to 8 into bracket VB plus 5. Is that taking? So if I expand, 2 times 2VA will give us 4VA 2 times minus 6 VB will give you 2 times minus 3 VB will give you minus 6 VB, and 2 times 40 will give us what? 80, equals to 8 times VB will give you 8 VB plus 8 times 5 will give us what? 40. Now if I collect like terms, we're having 4VA minus 6VB minus 8VB, right, is equals to what we have here now? This 40, this 80 that comes here, will now have this to be 4VA minus 14VB, right? Because minus 6VB minus 8VB give you plus 40 minus 80. Here, that what we have there, and that will give us minus 40. Is that okay now? So from here, 2VA minus 7VB, if you divide through by 2, 4 divided by 2 is 2, 14 divided by 2 is 7, and minus 4 divided by 2 is what? Is minus 20. So I'll term that to be my what? My equation what? Equation 4. Is that okay now? So when we've done that, so we're going to solve equation 2 and equation 4 simultaneously. Is that okay? Equation 2 and equation 4, we solve it what? Simultaneously. So if I should write out my equation, if I should write out my equation 2, it will give me 14VA minus 15VB is equals to 265. That's my equation 2. And equation 4 is 2VA minus 7VB is equals to minus 20. That is my equation 4. The reason why I'm taking this is because we're looking for what? VE and what? VB. Now, you apply any method of your choice. You can use your matrix, you can use your substitution method, or you can use your elimination method. And for the benefit of the viewers, I'll be making use of my word elimination method. Now, what I will do is, since I realize the coefficient of VA is not the same, right? I'm going to multiply both equation by their coefficient. How do I mean? I'll multiply equation 2 by equation of VA in equation 4, and I'll multiply equation 4 by the equation of VA in equation what? In equation 2. Is that okay now? If you multiply equation 2 by 2, why? Because it is the equation of VA in equation 4. So I'll now multiply through 47 times 2 will give you 94 VA. 47 times, 2 times 15 is what? 30 VB is equals to what? 2 times 2, 65. That will give us 530. I'll call it equation what? Equation 5. Right? Now, I'll do this similarly. I'm going to multiply equation 4 by the quotient of what? Of VA in equation 2, and that is 47. So multiply equation 4 by 47, I'll be having 47 times 2 will give you 94. 47 times 7 will give you 329, and 47 times 20 will give you 940. So this is what we have here. Don't forget the negative sign that we have attached to them. That will be my equation 6. Now what will I do? I'm going to subtract both of them. Reason is for so that the 94 will cancel out each other, right? So if I subtract it, minus 94 VA minus 94 VA will give us 0, minus 30 VB minus, don't forget this minus that is here, and the minus in front of the 329. So minus 30 VB minus, that will become plus. So minus 30 VB plus 329 VB. That will give us plus 299 VB equals to 530 minus is plus. So 530 plus 940 will give us what? 1470, right? So my VB now will not give me 1470 divided by 299. So VB will be equals to 4.916 volts, right? Now I'm going to substitute it into equation 2 in order to get what? VA. So my equation 2, if you like, you can use equation 4, any of the choice. So if I do that, I'll be having 47 VA minus 15 VB is equals to 265. So if I input the value of VB, I'll be having 47 VA minus 15 into bracket 4.916, right, equal to 265. So 47 VA minus 15 times 4.916 will give us 73.746 equals to what? 265. Now I'll be having 47 VA. If I take minus 73.746 to the right hand side, I'll be having 265 plus 73.746, and 47 VA will now give us 338.746. So my VA will now be equals to 338.746 divided by 47. So VA will now be equals to what? 7.207 volts. So this is what the voltage at node A, that is the voltage, the node voltage at A is what? 7.207, and the node voltage at B is 4.916. Is that okay now? So this is what we have here. So in order to get the value of the mesh current I1, I2, I3, I4, and I5, we input the value of VE and VB in those equations. So to help ourselves out, if you recall, my I1 is given to be 20 minus VA over 5. And if you put the value of VA, we'll be having 20 minus 7.207 over 5. And that will give us 12.793 over 5, which is 2.56 ampere. So the current at I1 is 2.56 ampere. Then similarly, we know the value of I2 is equal to VA minus VB plus 5 over 4. So if we put the value of VA and VB, we'll be having 7.207 minus 4.916 plus 5 all over 4. And this will give us 7.291 over 4, which is equal to 1.823 ampere, right? Similarly, I3 is giving us 30 minus VB over 8, and this will be equals to 30 minus the value of VB is 4.916 all over 8, which is equals to 25.084 over 8, and this is equals to 30.136 ampere. Now for I4, we know I4 is equals to VA minus 5 over 3. So if you put the value of VA, we'll be having 7.207 minus 5 all over 3, which will now be equals to 2.207 over 3, and this will be equals to 0.736 ampere. Then I5 will now be equals to VB plus 5 over 2. So what's the value of VB? That is 4.916 plus 5 all over 2, and this will be equals to 9.916 all over 2, and this will be equals to 4.958 ampere. So these are the value of the branch current that we have in this equation, in this circuit here. So if you have actually found this video helpful, please don't forget to like, subscribe. If you have any question, you can comment in the comment section, and don't forget to also what to share the video. Thanks for watching.